Computer Science 9618 paper 4, and today in this video we are going to understand about recursion, search, sort, stack, queue, linked list, binary tree. Let's start with recursion. What is recursion? Let's see what is recursion. So recursion is when you create a function, when you kind of print let's say a function, and you're just calling the function over and over again inside inside the function. The function is calling itself over and over until it reaches to the point where it just terminates. This is known as a base case. This is a condition where it will tell the function when to stop, okay, when to terminate. So we have created this writer program for calculating factorial. I just create this function and I have just put a value 5. 5 factorial is 5 multiply 4 multiply 3 multiply 2 multiply 1. N is equal to sum is equal to n multiply factorial n minus 1. So here's what's happening. I have just put 5 and then calling a function. I have just put 4 in here. It will be 4 multiplied by 3. This would be 3 multiplied by 2. This would be 2 multiplied by 1, and then after getting 1, this will terminate, because if n is equals to 1, return 1. This will return 1. 2 multiply 1, this will return 2, because you can see this return sum. 2 multiply 3, 6 return, so it will return again. 6 multiply 4, 20 multiply 4, 6 multiply 4, 6 for 24. This become 24 multiplied by 5, this would become 120. Then this is the answer. Let me just show you. If I run this, then I will get this 120. This is how it's working. And right in here I just put I've created this function, okay, because it's giving a value. So so it is giving a value because it is saving. You can see here it's returning a value, and then multiply and then sum, okay, and overall it will return something. So sum, so I just get in here fact 5, so it's returning, and I just print this 120. Another function, or you can say procedure. This is, I am not returning anything, but still I'm just printing the number of count. So count is equal to 0. This is my static int count, so that it could be incremented. If I put in here, if I put int c is equal to 0 in here, then it would not work, because it will just keep on calling itself, and then it will be initializing the c variable each time, so it wouldn't work. That's why I've put it in here, and I've put static in here, okay. And maybe I don't need to put static. I think it would still work. Okay, it will not work. Wait, yeah, it will not work because I have put static in here as well. So never mind. C is equal to 0. If c is equal to 10, then return. Okay, so I have just create this. C is equal to 0. C is I have just increment this by 1, so 1 got print. Then calling itself again, it will come again, increment, print, calling itself, keep on going until c is equals to 10, and then return. So this is the base case, okay. So it's working like this. Let me show you. So I got the count. C is equals to 0, it's going. C is equals to 1, it's going. C is equals to 2, keep on going until it comes to c is equals to 10. Return, returning itself, okay. But the main thing that we wanted to do is we just wanted to print this, okay. So this is recursion. It's just calling itself, and I think the time complexity is 2 of power n for this recursion stuff, okay. So let's move on. Now let's come to search and sort. We got what we have got. We got linear search, bubble sort, binary search, insert and sort. Let's start with linear search. If I put, let me just run this. This is my method. I've created this array. Okay, this is my function. I can say a method or procedure, whatever. It's not returning anything. I can say it's a procedure, or just okay, I can say it's a method. Okay, so I'm going to run this, and it's asking me the number, enter the number that you wanted to search. I'm going to search for this one, 390. So if I put 390, it will say found it at index 4, 0 1 2 3 4. Okay, let's try again. Let's say I put any random number. If I put this, sorry, not found it, please try again. Okay, now let's discuss the code, how it is working. First of all, I have just created this input, then it's printing that enter the number you want to search, and then I have put a loop in here, and the time complexity for this is on, because there's only one loop in the linear search. Linear search is so easy. It's very completely like you're putting a butter in a bread. Okay, it's easy, simple as that. So you got this loop, and you have, after getting this loop, you're saying that, okay, let me just come to the drawing mode. All right, this is my loop. Yeah, this is my loop. If array I is equal to the number that we want to search, if it is equal to this, then found is equal to true, boolean it becomes true, found it index this, and then it will break from the loop, because we don't need to do any more looping, right? We just break this out and we have done our job. Otherwise, if found is equal to false, we didn't found this, then this will be break. It's simple as that. This is linear search. Okay, let's move on. Now we got another one. Let's say binary search. Let me make this. So binary search, and I'm just searching for the 552. This is 552. Oh, sorry. In order for binary search to work, you need to make sure that the array is sorted. Okay. Okay. Yeah. Okay. Number one, whenever you try to use binary search, you need to make sure that number one, array is sorted. Ascending or descending doesn't matter. Let's say that it should be sorted in ascending order. And number two is then yeah, yes, then you can just use binary search. Then use binary search in sorted array. We always use binary search for sorted arrays only. Otherwise, if you wanted to search for this without any sorted, you can use linear search. Okay, so that's that. Binary search, let's, okay, first one I need to sort this. I'm going to do bubble sorting. We'll discuss this, how it's working. Value, okay, so now I have just sort this, and this is completely sorted. It's sorted. Value is found in index 7, 0 1 2 3 4 5 6 7 552. Okay, for what happens if I put something out of this? So what will I get? I will get, sorry, the value is not found it. Okay, let's start with binary search, then we will come to bubble sort. So this is our binary search. How it is working? Supposing that you got an array, and you did got an array, but I'm just giving another example. First of all, you got minimum maximum. So minimum maximum index min max. while min is less than equal to max, mid, you're calculating mid is equals to mix. Okay, let me just 1 2 3 4 5 6 7, max plus min is about 2, and you got the mid. So 0 1 2 3 4 5 6, 6 plus 6 upon 2 will be 3, 0 1 2 3. So this is our mid, and it's saying array mid is equal to, if it is equal to search value that we want to search for, then okay, you're done, break out from the loop. You're comparing the search value with this number. But if the search value is greater than, because obviously the reason why we put these greater than less than, because the array is sorted, okay, since it is sorted. So if the search value is on this side, then we can just take this one only, because mid plus 1 is equals to min. The min index will be updated, so it will come in here, and max will remain changed. Min max, okay, because it's saying search value is in here. This whole will be discarded, this will be used, and mid plus 1 is equal to min. So the min was in here, but then it came here because it got updated by 1. Mid plus 1, mid was here, mid plus 1, so this will become min. Or if it is less than, which means it might be in here, so could be in here, then you're going to update the max index, so max will come here, min will be remain unchanged. Okay, so it's like that. So while loop is completely here to here, if else if, and there you go, just keep on going like this while min is less than equal to max. And I've just put a boolean just in case. If found is equal to false, then sorry, the value is not found. So this is how binary search works. Let's move on. Okay, so this is binary search. Let's talk about bubble sort. Bubble sort is very easy, don't worry about it. So you got an array. Oh, it's so bad. My apologies. Let me use this beauty. There you go. Okay, let me use these numbers: 6 47 54 17 93 28. You got two loops, so the time complexity is O(n) square. Yeah, now this is the main thing happening in here. Okay, starting from j is equal to 0, this is j. Okay, if j is greater than j plus 1, if array j is greater than array j plus 1, these two are being compared. All right, which means that um, if this is greater than this, then it will swap, but it is not. Okay, this is less than 6, so it will just move on. Going again, j is equal to 1. Now j is equal to 1. This is j now. If array j is greater than this, no, it's not greater than. Again, move on. This one. If array j is greater than this, yes, it is greater than this, then swap. How it is swapping? Temp array j plus 1 is saved in a temp. It's saved in a temp. Okay, yeah, array j plus 1. Okay, and then it is saved in a temp. Okay, array j, so this is coming in here now. It comes in here, it override the data because the data is already stored in temp, so it's override this, it comes here. 54 is now in here, and then temp will come in here. So this is how you just done a swapping. So it's swapping happened like this: 6 47 17 54 93 and 28. swapping is done. Now the value of j will come here. Now this is it's pointing to this. 54 is greater than, no, j comes in here. 93 is greater than, yes, swap. 23, 28, 93, 54, 17, 47 and 6. But now you can see here that it's completely over, but it's still not swap, which means that we need to put another loop outside, or we can put a loop, for loop, or we can just put a repeat until, and we can play with boolean that like for example I'm going to create a boolean flag is equals to false right here, and then if this is greater than this, then I will make it true. Okay, and it will just keep on running. Repeat until repeat until flag is equals to false. Flag is equals to false. Yeah, but flag is equals to 2, so it will just keep on going. Wait, or maybe you can just say flag is equals to, I'm going to create flag is equals to true. Okay, repeat until flag is equal to false or true. Let me just do it. Let me show you guys, because you can either put a loop in here. Okay, you can just either put a loop and it will work, but for example that array is already sorted, and then you again keep on going doing the looping stuff, but that would be inefficient. Memory is wasting. Okay, so you need to write an efficient code. So let me write it down for you guys. So I'm removing this loop stuff. I'm just going to remove this. Repeat. Okay, there is no repeat in Java. There is no such thing as repeat. There is only while do. Okay. So let's say do, then while. Let me just create a boolean flag is equals to false. Okay, now it will keep on going. If it is equal to this, then this will become flag becomes true. Flag becomes true. Okay. The loop is in here. After that, after it's gone, after the loop is done, okay, so this would be in here. Flag is equals to false. Okay, this would work. Flag is equals to false if there's a if it's any number which is greater than, if it's any number, j is j plus 1, then it will becomes true. This loop will keep on going, and when it's complete, when it's done, it will come out and it will be checked. Okay, while flag is equal to true. While it is true, it will just keep on going. Okay, it will just keep on going while it is true, otherwise keep on going. So now let's check again. Let me just run this again. It should work. So if I run this, giving me the same output, which means it works. Okay, so you can just put a for loop, or you can just do with this. You can just put a boolean. Okay, do flag false. If this happen, then flag true, and it will give another round. It means that will will give another round if flag is equal to true. Okay, so this is bubble sort. Or if you're not, if you think it's quite difficult for you guys, then you can just put a loop and voila, it's done. Bubble sort is very easy, don't worry about it. Yeah, bubble sort is so easy. You just put a two loops, and then you just put this, and you just done the sorting. It's quite simple. Okay, another important thing to tell you guys, that if you put this sign, it means that you are doing in ascending order for the array. If you put this sign, this would mean that you're doing descending order. All right, let's move on. Now we got insertion sort. Let me show you if this is working or not. Again, it's still working, which means this also works. Now let's see how it did work. Okay, let me give you an example. Okay, so I'm going to use these numbers 6, 47, 54, 17, 93, and 28. Pointer is equals to 1, so this is pointed to this number ptr. Then the array pointer is temp. Now it's stored in a temp. So similar thing like bubble sort. Okay, so temp is being it's saving temp. Backward, another variable came. Backward is equal to pointer minus 1, so backward is pointing to this. Now backward is greater than or equal to 0. Yes, it is equal to 0 at some point. Yes, it is equal to 0. Temp is less than array backward. Temp is less than array backward. It's saying that, is this number less than this? No, it's not less than 6, so this loop will be skipped. It's saying that backward plus 1, backward plus 1 is equal to temp, so nothing changed after that, and you just go another round. So I'm going to copy this. All right, now PTI is pointing to this. It is safe in a temp. Backward is came here. Now if this is less than this, no, it's not. So again, keep on going. Okay, Now PTR is in here, backward is in here. Is this less than this? Yes, it is less than this. This is safe in a temp, and then this temp is being compared to this. It is less than 6. Okay, 54 will come in here. This is what happening. Backward plus 1. Backward plus 1 is equals to array backward. Backward plus 1 is equals to backward, which means 54 will come in here. Backward minus minus. Backward minus minus. Backward pointer come in here. Comparing again, because it is in while loop. Temp is less than this. Yes, again comes in here. Pointer will come in here. 6 is less than this. No, temp is greater than this. So nothing changed. It came out from the while loop. Then said backward plus 1. Backward plus 1 is equal and temp. So temp will come in here. So it would look something like this: 6, 17. We got 47, 54, and 93 and 28. So this is how this insertion sorting is work. You're inserting in the right time, in a right position. Insertion sort, inserting it, taking it out, doing the sorting, inserting it back. So this is the name of insertion sort. Okay, so keep on doing like this and you're just going to get this answer. This is the whole coding. Okay, so we are done with search and sort. Okay, I think it's enough for now. Thank you so much for watching. We'll discuss linked list binary tree in the next video and